This is the introduction to section 6.2, part 1, and in section 6.2 we're going to start to discuss more about quadrilaterals, four-sided shapes, and we're going to get into specific types of quadrilaterals, and the type of quadrilateral we're going to talk about is a parallelogram. Okay, and a parallelogram is a quadrilateral with both pairs of opposite sides that are parallel. Now, opposite sides are sides that don't intersect. You'll notice here they have the single lines on them. These are opposite sides, the left and the right, and the top and the bottom. Those are considered opposite sides. Now, the objective that we're going to look at today is we're going to use relationships amongst the sides and angles of parallelograms and discussing what a parallelogram is. Again, a parallelogram is a quadrilateral where both pairs of opposite sides are parallel. Now, in a quadrilateral, opposite sides do not share a vertex and opposite angles do not share a side. So, as you look at this example here, again, opposite sides do not share a vertex. If I go to circle these here, these guys right here are opposite sides. In other words, they do not intersect. They don't share a point, common point. And opposite angles, which I'll circle in red right here, opposite angles, in this case, do not share a side. So as you look at these opposite angles, this angle down here in the bottom corner shares these two sides. The angle on the top shares these two sides, and you'll notice those two sides are not the same. Okay, so they do not share a common side. Now, as we look at here, in a quadrilateral, opposite sides, again, do not share a vertex. They do not share the same side. It shows you another example there. You can abbreviate a parallelogram with the symbol. It's almost like a sidewards rectangle. In parallelograms with the symbol, the sidewards rectangle with an S in it. Okay. Now, what we're going to go through, and we're going to talk about some theorems that, if you know that it's a parallelogram, some more specific parts about it. Okay. So the first one that we're going to talk about here is if a quadrilateral is a parallelogram, then its opposite sides are congruent. So, as you look here, we have parallelogram ABCD. It's a parallelogram because opposite sides are parallel. And if we know that if it is a parallelogram, then we also know that AB and CD, these opposite sides are congruent to each other, and BC and AD are congruent to each other. So, opposite sides are congruent to each other. That's one of the theorems. Now, as you go through all these theorems, you're going to want to study these because these are very important to what you're going to look at on homework. The other thing that we talk about with parallelograms, in this case it says here, angles of a polygon that share a side are consecutive angles. In this case, A and B are consecutive angles because they share side AB. So here's side A, or angle A. Here's angle B. They are consecutive angles because they share this side right here. Just like D and C are consecutive angles and they share side DC. Also, side or angle A and angle D are consecutive angles, and I'll circle these guys in blue. A and D are consecutive angles because they share side AD. Okay, along with B and C. B and C are consecutive angles because they share side BC. Okay, so two angles are consecutive when they share the same side. I think of it as they're one right next to each other. You don't skip angles, in other words. Remember, consecutive in one way means one right after the other. Okay, theorem 6.4 says that if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. In other words, their consecutive angles add up to 180 degrees. And you'll see here what they've given you here. A and B are consecutive angles. They're right next to each other. They're going to add up to be 180 degrees. B and C are consecutive angles. They add up to be 180 degrees. C and D are consecutive angles. They add up to be 180 degrees. And A and D are consecutive angles. They add up to be 180 degrees. Now, B and D, these are not consecutive angles. Those are opposite angles, okay? Those are not consecutive angles. They're not one right after the other. You notice you skip A to get to B, or you skip C to get to B from D, okay? So only consecutive angles are supplementary. Okay, now talking about opposite angles, we just got done talking about that a second ago. It says if a quadrilateral is a parallelogram, then its opposite angles are congruent. Well, in this picture, angles A and angle C are opposites of each other. You can draw a straight line from angle A across the shape to angle C. Okay, those two are congruent to each other, and then same thing goes for B and D. Those are opposite angles. They're congruent to each other. So, consecutive angles are supplementary. One right after the other, they add up to 180. And opposite angles are congruent. Now, let's take a look at a couple of examples here of what you might see on some homework. Okay, it says find the indicated measure in parallelogram KLMN. So it's already decided that it's a parallelogram. Now, as you look at the picture, they've given you some things here. They've given you a pair of opposite sides. And you know that since they're opposite sides and it's a parallelogram, you know that the opposite sides are congruent. So we know that 2x minus 3 is going to equal 37. And then I can solve this measure for x, because I know that the opposite sides are congruent. So if I add 3, that's going to be 2x equals 40. And when I solve, x equals 20. So in this case, the value of x is 20. Now, how do you check to make sure? If you plug that back in here for x, it better be 37, because they both have to be the same measure, because they're opposite sides are congruent. Okay. So if I plug that back in, 2 times 20 is 40, minus 3 is 37. So we check it out. Now, letter Y. As you look at letter Y, you'll notice letter Y is an angle measure, and it's opposite of the 123-degree angle. Well, remember, in a parallelogram, opposite angles are congruent. So therefore, Y has to be 123 degrees. Okay? And then finally, Z. Z is not opposite of 123, but it is consecutive to it. They're right next to each other. So I can say that Z plus a 123-degree angle are going to be equal to 180. Again, they're consecutive, so they add up to be 180. Solve for Z, and I get Z to be 57 degrees. Okay, so this concludes part 1 of section 6.2. We talk about parallelograms and the characteristics of a parallelogram and being able to find the different measures of angles and the different measures of sides and the length and the value of x. Don't forget to complete your WSQ once you've finished watching the video.